Hello, Bio20. Welcome to our final video on the excretory system. Today, we're talking about hormones. This is a huge concept that comes forth in Bio30. So today's video is actually probably the most important out of this entire unit. We're going to learn how different hormones regulate blood pressure in our body. Today's your goal is understanding the hypothalamus and the pituitary gland in the brain. What is ADH? What is aldosterone? And what are their roles? All right. So moving into this, let's talk about water balance. When I say water balance, we're talking about the movement of water to and from your kidney. The amount of water that is reabsorbed from your kidney into your blood from the filtrate actually has a massive impact on blood pressure, so the volume, as well as the amount of concentrations of solutes in your blood. So if we take a quick look at this picture over here, you can see that there's very little salt located here, but a lot of salt located here. All right. When we're talking about reabsorption, we are moving water back into our bloodstream to deal with this. We do not want high concentrations of solutes in our blood. We want a nice balance. So water passively, through the process of osmosis, moves from your kidney back to your blood to deal with high concentrations. I forgot to mention, at any point you see bolded words, underlined words, these are what are being added into your notes. So let's talk about the brain. The brain is a big deal, and we talk about it in Bio30, and it's one of my favorite parts of the year. I love talking about the brain. Now, the brain is such a cool and unique thing. Obviously, we have a very unique brain to most animals here on planet Earth, but here is the outside part that makes us taste, touch, see, hear, and think, higher order thinking, feelings, emotions, stuff like that. That's the outside. In the inside, we have something called the limbic system. The limbic system is what you would find in most animals with a less developed outer part of their brain. Okay. Now, inside that limbic system is the hypothalamus. The hypothalamus is actually a massive regulator for something called the pituitary gland, which is where all hormones are located. Not all, but most. So what happens here is that the osmotic pressure, so the amount of water in our body, is actually affecting the hypothalamus through something called osmoreceptors. There's these little tiny cells, osmo meaning water, so cells that respond to water. And when water pressure is low or we're feeling dehydrated, the hypothalamus sends a little message to the pituitary gland and says, hey, we need a little something called ADH. ADH is the antidiuretic hormone. As a hormone, its job is to ensure that water doesn't stay in the kidney but gets put back into the blood. So if we take a closer look at ADH, it's right here in the pituitary gland. So ADH is secreted from the pituitary gland down to the two parts of the nephron, which is the distal tubule and the collecting duct. Super important, guys. You need to know where that is. Now, the point of ADH is to increase permeability. What is permeability? Essentially, it's like opening the doors wider. Okay, permeability is making it so things can move freely back and forth. ADH goes to the cells in the collecting duct in the distal tubule and says, hey, you have water in there. I want it out. So it opens up the cells and water leaves the kidney and goes back into the blood, which increases blood pressure, increases the dilution of solutes. As we take more and more water back into the blood, what happens is those little osmotic receptors, so osmoreceptors in our brain, recognize that the pressure has been raised and they tell the pituitary, stop secreting ADH. We're good, we're done. So ADH has got a huge role in regulating how much water is put back into our blood. Now, if we were to look at a closer picture, this is what we're trying to look for. ADH's role is to ensure that we do not have too dilute of urine or too concentrated of urine. So if it is too dilute and the osmotic pressure is low, we're not secreting ADH. ADH hasn't been secreted, it's not happening. Okay, you're looking for something like this, normal output, which is about 2 liters of urine per day. Now, that being said, if the water is we're excreting too much water out of our urine, our output is too high, you're going to end up with something called polyuria, which is an extreme high output of urine. This is bad. And we're going to talk about what this means here in a second. This one down here, oligouria, is when you you excrete way too little urine. And this one is when you're not even excreting any urine, anuria. But essentially, guys, the whole idea behind the ADH is to ensure that your blood has enough water in it to remain hydrated. What that means, though, is if you're not drinking enough water, your urine is going to be very dark. It's going to be a nice dark yellowish color because you are dehydrated. Your body is holding on to as much water as possible, but you're not adding enough in, so you're not excreting any. Let's say someone is suffering from a huge output of urine. Okay, so you are excreting 4 liters, 8 liters, 20 liters. Could you imagine 20 liters of urine per day? Okay, this is bad. This is usually what means ADH is broken. When you have ADH not working properly, you can suffer from something called diabetes insipidus. Now, diabetes insipidus is not to be confused with diabetes mellitus. Diabetes mellitus is type 1, type 2 with insulin. That's the more common one that you would think about if I said the word diabetes. Diabetes insipidus, the word sip is in there, sipping on water. It means that the regulation of water output is broken. So ADH secretion has decreased or stopped, and now we're getting rid of way too much water in a day. So you're excreting 4, 8, 20 liters of very, very dilute urine. Dilute means it's very, very light in color. Please make sure you star that. When you do this, your body is so unbelievably thirsty. Why? Because you're not hydrated. You're not keeping any water in. You're literally chugging water to pee it out. That is what is happening. ADH is not going to that distal tubule. It's not going to that collecting duct, and it's not gathering that water. You can actually suffer from massive dehydration, huge ion imbalances, and you can get very sick, and it can cause so many problems. How do they treat it? It's just a simple shot of synthetic ADH. When you put it back in your body, you can help restore that water reabsorption, but you will be on synthetic ADH for the rest of your life as your body does not properly make ADH. There's another part to this story, and that is caffeine and alcohol. So caffeine and alcohol are known as diuretics. It's interesting how it's an anti-diuretic hormone. Caffeine and alcohol are diuretics. What does that mean? Well, it means it increases the volume of urine output simply because they trick your body into thinking that you need to release ADH. Okay? So what it does is, I said it makes you release ADH. It makes you stop releasing ADH. Sorry, guys. So diuretics decrease the release of ADH. When it does that, is it actually says, hey, don't worry about it. We got enough fluids in here. You can get rid of as much water as you want. So you secrete water and you secrete water. So you're putting water into the kidneys and then you're peeing it out. But that's a problem because it actually leads to dehydration, and you become thirsty, and you can actually become very sick again if you drink too much caffeine or have too much alcohol. So the diuretic ends up causing you to be more thirsty than if you were to just drink a glass of water. This leads us to our very last idea, which is aldosterone. So we just talked about water being put back into our blood, but there's another way we can do it, and it's through sodium concentrations. Sodium ions are actually really important and play a huge role in how your body sends messages through neurons all over your body. So sodium has a huge role. So we need to keep it in our blood to ensure that we can use it all over our body. But sometimes, due to what we eat, that sodium concentration can fluctuate immensely. Okay. So what ends up happening is we end up having to regulate this through a hormone called aldosterone. When sodium drops, so your blood is running around, all of a sudden your body realizes, I don't have enough sodium. It triggers the release of aldosterone. Aldosterone's job is to go to the distal tubule and the collecting duct, same place as ADH, and take any sodium it finds in that urine and put it back in the body. Now, the cool thing about sodium is as a positive ion, it naturally pulls chloride with it. It also highly attracts water because water is like, oh, now there's all this concentration of solutes in the blood. I should follow. So aldosterone indirectly affects blood pressure and increases the volume of water in your body. So it's meant to be for sodium, but it has a very cool side job, which is helping you deal with your blood pressure. So that is all, ladies and gentlemen, on how water is balanced in our body. If you have any questions, please ask. We are going to be looking at aldosterone, ADH, and something called dialysis as we move forward into our final assessment for this chat.